Hey, welcome to The Explainer. You know that feeling when you're staring at a huge wall of text and you just know there are patterns hiding in there, waiting to be found? Well, today we're diving into the tool that lets you do exactly that, regular expressions. Okay, so let's kick things off with a super common problem. You're searching a document for the word gray, but you also need to find the British spelling, gray. Using a standard find function, that's two separate searches. It's a pain. There has to be a better way, right?
Well, there is, and it's called a regular expression, or as pretty much everyone calls it, regex. The magic of regex is that it doesn't just find words, it finds patterns. And trust me, it's a total game changer for anyone who works with text, from developers to data scientists and beyond.
So, what exactly is a regex? Think of it like this. It's a tiny, super specialized language built for one single purpose, to find patterns in text. And it is incredibly good at its job.
All right, so the simplest kind of regex is what we call a literal match. If your pattern is /Waldo, it's going to find Waldo. Simple enough. But, and this is important, look what happens when Waldo is lowercase. No match. And that right there is a really key thing to remember. By default, regex is case sensitive.
But, just matching exact text, that's only scratching the surface. The real power, the real magic of regex comes from its special characters, or meta characters. So let's get into the basic building blocks of this new language. First up, the wildcard. In the world of regex, the wildcard is just a simple period, a dot. Now, this little dot is basically a placeholder. It can stand in for any single character, a letter, a number, a space, you name it.
So, let's see how this actually works. A pattern like /hg/ will match hug, h_g, and even h8g. That dot in the middle just means, hey, any character here will do. Same with /pointun/, it'll find fun, run, or sun. See what's happening? We're not just searching for words anymore, we're actually matching patterns.
Okay, so a wildcard is cool and all, but sometimes it's a little too wild. What if you want to match a character, but only from a specific list of options? That is where character sets, defined by these square brackets, come into play. Now this is where you get some serious control. The pattern BIUG will match bag, big, or bug, but it won't match bog or beg. You can also define ranges, which is super useful. So from /A to Z means any lowercase letter, and from 0 to 9 means any single digit. It's all about being precise. Okay, so we're building up our toolkit here. What if you need to choose not just between single characters, but between entire words or phrases? For that, we use the pipe symbol. Think of it as a logical OR. So for example, you could write a pattern like /dog, /cat, /bird to find any one of those three words. But check out that second example, /gray a, /gree, /y. This pattern tells the engine to find gray, then find either an A or an E, and then find a Y. And boom, just like that, we've solved our very first problem, finding both gray and gray in one single elegant search. All right, so now we can define specific characters. We can make choices. What's next? Well, the next level up in regex mastery is all about repetition, telling the engine exactly how many times a character or a group should appear. Let's break down the two heavy hitters here, the plus sign and the asterisk. The plus sign means one or more of the character before it. So /AB plus C will match ABC and ABBC, but it won't match just AC because the B has to be there at least once. The asterisk, on the other hand, means 0 or more, which makes that B totally optional. That's why /AB*C matches AC. It's a really subtle difference, but trust me, it's absolutely crucial. And believe it or not, you can get even more specific. A question mark means 0 or 1 time, which is perfect for optional letters, like the S in color versus colors. And for ultimate precision, you've got curly braces. You can specify an exact number, a minimum number, or even a specific range. The control you have is incredible. Okay, so up to this point, we've basically just been asking a yes or no question. Does this pattern exist in the text? But what if we want to change how that search works? Or better yet, what if we want to pull out the text we find? For that, we need to talk about flags and extraction methods. Okay, let's focus on two of the most essential flags you're going to use all the time. The I flag stands for ignore case. This little guy solves our Waldo versus Waldo problem from the beginning. Then there is the G flag for global. This tells the search engine, don't stop at the first match you find all of them.
And here's where we put it all together. Let's say we use our .match function with our pattern twinkle by adding both the global and ignore case flags, that GI at the end, we can search the entire string for both twinkle and twinkle. And the result? It's not just yes, it's an actual list containing both words. We've successfully pulled them right out of the text.
You know, all this stuff feels super modern, right? Like something straight out of today's coding world. But the idea behind regular expressions, it actually has a surprisingly deep history, stretching way back into the world of theoretical computer science.
So, the whole story kicks off way back in 1951 with a mathematician named Stephen Cole Kleene. But the really big leap came in 1968 when the legendary programmer Ken Thompson actually built regex into a text editor, and that led directly to the famous Unix tool grep. Fun fact, grep literally stands for Global Search for Irregular Expression and Print. Then, in the 90s, the programming language Perl came along and supercharged regex, creating the powerful syntax that is now pretty much the standard everywhere.
And speaking of Perl, its creator, the one and only Larry Wall, had this great quote that just perfectly captures the vibe. It shows how this really powerful, almost academic concept became such an integral and even playful part of programming culture.
So, here's the bottom line. Regular expressions aren't just some obscure tool for programmers. They are a completely new lens for looking at text, a way to see the hidden structures in language and in data. Patterns are absolutely everywhere. You now have the key to their secret language, so the only question left is, what are you going to find?